They're reviewing the parameters to move the
Okay, I
mirrors.
see those parameters look good. You are good to move the motor.
Copy, go to move to see how to move.
Copy that.
And this will move the mirrors into their final position.
Now complete.
The screen to the right shows us our ground station.
And the motor status is moving.
You can see the mirrors move in the visualization tool. It will take about 4 minutes for them to completely come forward.
And a reminder, this is real live footage. There's a 3-second time delay. It takes that long for light to travel at 186,000 miles per second. The James Webb Space Telescope is now well over 600,000 miles away.
And
thing to remember about this.
Go ahead.
I was just going to say, just remember that this visualization is real. This is not pre-recorded. It's based on actual data coming to us from the telescope, being downloaded right now.
And the important thing about the light delay is not that the light takes that long, but the data, which moves at the speed of light, takes that long to come to us. I know that was a question we had on some of our social media before.
Ops with the status, we have started our deployment into the deployed hard stops, and our current looks really good, nice and low.
Mount copy.
That was another of our deployment engineers confirming that everything looks good with our mission operations manager.
It's exciting to actually see it moving. You know, there it is on the visualization tool. It's getting closer and closer.
Yep, it's going to be momentous when it finally comes into position.
The first wing was successfully deployed yesterday, and now this is the final part, the primary mirror being put in place. Julie, give us a sense of the scale. These mirror segments. I mean, I had the honor of watching this being built, a lot of it at Goddard. How big across, for example, is one of those hexagons?
They're about 1.5 meters across from tip to tip. The hexagons are quite large. It's amazing to actually be in the clean room and look up to see the whole mirror assembled, towering above you. There's no amount of seeing it on photos that kind of gives you the sense of actually standing next to it in our clean room when it was assembled. And as we talked about before, and once it's fully into position here, the final shape that our primary mirror is going to be called a tricontagon. It's about a polygon.
The step lead on ops, we're about 3/4 of the way through the deployment, and everything still looks really good.
And the mirror itself will be concave. You can sort of just see that in this simulation. They actually have simulated some stars and things in space that you can see moving on the surface of the mirror. Also, as the mirror comes forward, and I'm not sure that we can see it at this angle, but there's a thing called the bat wing, and it's a shade that falls down behind the mirror to help shade any light or heat that might be coming up through the hole in the sunshade from keeping any of the backside of the telescope warm. There's one on each side that comes down passively as the motor moves this forward. And then the gaps between the mirrors are very small. I think it's on the order of several millimeters.
This is step lead on ops. We have reached the end of deployment, and we are preloading into the latch pads.
All right.
Okay, copy.
You see people clapping? Yes. Wonderful
Everyone's
moment.
up on their feet and clapping.
Wow, just look at that. The primary mirror is successfully deployed. This is a first. We have made a space observatory the mirror was so large that it had to be folded up to fit inside the
Hey,
rocket.
OC, at this time we're ready to continue with 693.046. Enable activate SCS 256.
Okay, copy.
And that command line looks good. You're go to execute.
Copy that. Proceed. Go ahead and execute.
Executing.
I think you can hear the relief in our